Hi, everybody. Dr. White back again with the second screencast on the section 4.1 topic of normal distributions. Last time we talked about what continuous random variables are in general and how their probabilities are given by their density curves. And then we talked about the family of normal random variables. They have what are called the normal distributions, those bell-shaped curves that are determined by two numbers, their mean, the number in the middle, and their standard deviation that say how spread out they are. And we talked about the 68-95 rule for probability when your random variable has a density curve that looks bell-shaped. And we talked about how you can use that 68-95 rule to get some basic probabilities for normal random variables. But for just any kind of general probability question involving a normal random variable, you're going to need more than the 68-95 rule. So we're going to learn about an R function called pnormGC that comes along with Tiger stats. P for probability, perhaps. Norm for normal, and GC, you can think of that as graphical calculator. Say that we're back with that population of college males whose mean height is 72 inches and the standard deviation of their heights is 3.1 inches. Some big population of college males, and we are selecting a college male at random and measuring his height in inches. So apparently the average height of the population was 72. And we call this random variable X. Now, suppose that you wanted to find the probability that X, the height of the randomly selected male, is bigger than 70.9 inches. How would you do that? Remember, the 68-95 rule won't work here because 70.9 is not like 1 or 2 or 3 standard deviations above or below the mean. So here's how you do it. pnormGC, parentheses, because you're going to use this function. And the first input is your boundary number, the 70.9. And then you want the probability that X is bigger than 70.9. So you say region is above the 70.9. Then you got to say what normal curve you're asking about. Well, we're asking about the one where the mean is 72. That's the next input. Standard deviation is 3.1. That's the next input. And we also it'd be nice to get a graph of this normal curve showing the shaded area. That's graph equals true. So if you were to run this in RStudio, you will get a graph that looks like this in the plot window, and over in the console, you'll get the probability. So let's give it a try. Whoops. So I'm going to copy, head over to the RStudio server, paste, run. And I'll move my face. See if I can move my face. Face, move. I'm just going to get rid of my face. And sure enough, so the area under the normal curve past 70.9 is what gives you the probability of the random variable X being bigger than 70.9. And that chance is 63.86%, 0.6386. It's more exact over here in the console, 0.6386448, but basically about 63.86%. Okay, let's try another one. What if you wanted to find the probability that X is less than 69 inches? Well, same thing, boundary number, but this time you say region is below. Everything else about it is the same. So I'll just show you what you get over in this next slide. So you can tell that when you ask about probabilities for a normal random variable, you don't have to be looking at this graph. You don't have to say graph is true. But in your mind, you should draw a bell-shaped curve with the 72, the mean, stuck in the middle, and then your 69, and then like shade in the area before it. Or even do that on a sheet of paper with an actual pen and pencil. Anyway, this time, this area here that's shaded in is about 16% of the total area underneath the curve. 16.66% to be more precise. Sometimes you want to find the probability that a random variable, a normal random variable, will turn out between two numbers. Like, what's the probability that that randomly picked college male turns out to be between 69 and 72 inches in height? Well, this time with pnormGC, you're going to need to give as your first input the two boundary numbers stuck together with that C function. And so C function there, and then the parentheses because they're using it, and the two inputs are the 69 and the 72 separated by that comma. That's the first input. And then you've got a comma for the next input of pnormGC. You got to say region equals between in quotes, and then everything is the same. Your normal curve as specified by its mean and its standard deviation, and I'm asking for the graph, so we get this kind of picture in the plotting window, and the probability for the person to be between 69 and 72 inches is about 33%. Very occasionally, you'll want to find the chance of being outside in some region. Like, what's the probability that the person is either less than 69.9 inches or more than 75.1 inches? Again, it's pnormGC, and again, it's your boundary numbers stuck together with the C function. But now you say region is outside. Everything else is the same. And here's your probability, 31.73%. That 0.3173 is the sum of this area here and this area here, because you're asking for the person to be less than this or bigger than this. Now, when you ask for the random variable to be less than a number or bigger than a number, you might wonder whether it matters if you say less than or you say less than or equal. Like, say you got a continuous random variable x, and you're thinking about the probability that x is less than or equal to x, like right over here where I'm circling. That's actually the same as the probability that x is less than x. You can leave off the equal sign here. And why is that? The reason is that the probability for a normal random variable to be exactly anything, like the probability for the normal random variable capital X to be exactly that value little x, is actually 0. And why is that? Well, let's look at what pnormGC would tell us for the probability for our normal random variable to be exactly some number. Like, how about the probability that the student is exactly 73 inches tall? Well, according to what we've learned, we would say pnormGC, our two boundary numbers, and they're both 73, region is between. So we're asking for the person to be between 73 and 73 inches. Mean and standard deviation just the same as before, asking for a graph. And check it out. The area underneath the curve from 73 to 73 would be the area of this vertical line. And what is that area? Well, you know, for a rectangle, the area would be base times height. We got a height here, but our base is 0 wide. 0 times a height is 0. So this area here is 0. There is a 0% chance for a person to be exactly 73 inches tall. Now, let's think about this. I'm going to just grab this code, head over to the RStudio server. I'll make it a little bigger for you to see. And let's ask for the probability for a person to be, how about 70.83 inches tall exactly? And so I'm putting both those numbers to be 70.83. Well, that's 0 as well, because again, it's just a little straight line that has area 0. No matter what number I put in here to find the probability that it's equal to exactly that number, that probability is 0. So this is very interesting. You know, you've got some height, you are exactly some height, but the probability that you ended up having exactly that height is 0. So probability being 0 is not actually the same as impossible, not when you're dealing with a continuous random variable like these normal random variables. If you'd like to review and practice more with using pnormGC, you can follow this link here. homerhanamat.github.io/tigerstats/pnormGC. You can follow that link when you get these slides. I'm going to follow it right now. I'm going to open that link in a new tab. And you come to a tutorial that has a little table of contents here, so you can skip down to finding any particular type of area that you like, and you can get a few examples for dealing with it. I'll take my face away. In general, if I just go here to TigerStats, I'm going to the home page of this package. So homerhanamat.github.io/TigerStats. And you'll come to this web page, and if you look under vignettes here, you'll actually get some tutorials on how to use a lot of the R functions that we use in this course. So we'll be coming to this web page every so often. You might want to bookmark this page. That's all for now. Next time, we're going to talk about a concept that's kind of opposite of probability, the concept of percentiles. See you soon.